So this video is going to cover binary systems. So we'll look at some terminology, what binary is. We'll look at numbering systems, codes, logic gates, digital I/O, and pulse width modulation. So when you think about a computer, it's really built up using transistors. And so a transistor is kind of an electronic device that for digital systems is a switch. And this, what's shown over here on the right is a sample of a simple switch designed of two different transistors hooked together. So this one here, this bubble represents a knot or a flip of it. So if you put in a high into A, then it will give you a low out. So this A bar here means the opposite of A. So this is what we call an inverter circuit. And so a 1 in gives you a 0 or a low out, and a 0 in will give you a 1 out. So this is about the simplest type of digital circuit that you can build using transistors. And so the top transistor here is like a P-type transistor with the bubble, which is the opposite of the N-type down here. And so effectively the way this works, if this is a 1, then it turns on the lower transistor, and then by turning on the lower transistor, you're bringing it down low. And if this is a 0, then the lower transistor is turned off, but the upper transistor is turned on, which is pulling the output high. All right. So when we think about controllers or computers in general, and everything in there is represented in a binary form or of ones and zeros. And so to get things like letters in there, like the letter A, capital A, or lowercase a, semicolons, any kind of information that we think of that we normally like just reading a screen or reading a book or something. If we want to get that in the computer, we have to represent it as a bunch of ones and zeros. And so to do that, then we have to encode those symbols so that when they're in the computer, they're actually going to be stored as a group of ones and zeros. So we'll look at that in more detail in a little bit. Let's first look at the definition of binary. Okay, so this is just from a Google search here to get a technical definition. Binary can be an adjective, meaning it's relating to or composed of two things. It's relating to using or expressed in a system of numerical notation that has a base 2. Or if you think of it as a noun, you're talking about a binary system or a binary notation, meaning that it has two parts, or for binary numbering, we think of two symbols to represent the value. So those two symbols are a 0 and a 1. All right, so when we talk about computers, we usually talk about ones and zeros, but in reality, inside the computer, it's a high voltage or a low voltage. Okay, so you can think of like a high or low, true or false, or 1 or 0. So we tend to kind of swap back and forth between those. But physically inside of the computer, when we say there's a 1, we're talking that there's a high voltage. Okay. So binary computers are actually digital computers, meaning that they just run on these two states of high or low. And so a binary numbering system is represented as base 2 meaning that the only symbols in this number are made up of ones or zeros. So first, let's talk about the decimal system. We're very familiar with the decimal system. We've pretty much used it our entire lives. In the decimal system, we basically count by tens. And so this is referred to as the base 10 system, meaning that there's 10 symbols. However, keep in mind that one of those 10 symbols is a zero. So you have a 0 and then 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So to display the number 10, you have to display a 1 in the tens column and then a 0 as a placeholder in the ones column. Okay? So here, if we kind of look at this, we see that it's just kind of broken down here of the different columns. So if you think about a number, right, you have the ones column, the tens column, hundreds, thousands, 10,000s, 100,000s, millions, and so on. Okay. So as I mentioned before, right, if we're going to put data inside the computer, even if it's just a number like, 364 or, whatever number you want to put in there, to put it inside the computer and store it, it has to be a set of ones and zeros. So we have to encode these values in there. So this slide's basically just saying the same thing here. We just have to convert it to a bunch of ones and zeros to store the data. So let's look at converting values. So first of all, let's just go back and look at the decimals. So remember, deci means 10, and so this is our base 10 system. And so you can break it up into like ones, tens, hundreds, thousands, and so on. So if we look at the number, say I just picked a number here, 43,275,118. What we're saying here is that the 4 is over here in the 10 millions column, right? So this means 40 million. And then we have the 3 in the 1 millions, so that's 3 million. So we have 43 million. And then we have 200,000, 70,000, 5,000, and we're basically just adding these all together. So we can kind of do the same thing for base 2 then. So if you go to base 2 though, your weightings are based on multiples of 2. So let's go back here for just a minute and look at this, right? So we have the ones column. So here we have 8 ones, and then we have 1 10, and we have 1 100, and we have 5 1000s. Okay, but each one of these columns, right, is going up by 10. So you have 1, 10, 100, 1,000, and so on. But when you're doing base 2, you're only going up by 2. So at first that seems kind of small. You're going up 1, and then 2, and then 4, and 8. But it starts going up faster as you go along, right? Because each one of these is multiplied by 2. So here we have the ones column. You'll always have a ones column. So, but then you have 2 times 1 gives you 2. And then 2 times 2 gives you 4. 2 times 4 gives you 8, and so on up the line. So if I had a number such as a binary number of 1110, 1110, right? So this is what we would call an 8-bit number. So a bit refers to one storage location or one transistor circuit, like I showed you earlier, basically, which is either a 1 or a 0. And so that bit, then you group those together, and if you put 8 of them together, you get what we call a byte, which I'm sure you heard of the term byte, right? If you're going to buy a computer, you talk about, oh, well, we have so many bytes of memory and various different things like that. So we're going to have a byte. So this is a 1 byte, okay, and it's made up of a series of ones and zeros. So if we wanted to then convert that into a decimal value, or actually like, okay, so the top of this here, we're saying I have 242 in base 10, and I want to convert that to binary. And so the way you do that basically is you kind of start from the left-hand side. So you look over here, we have 128. So I'm going to take 242 minus 128. And I'm going to ask, before I really do this calculation, I'm simply going to ask, is this going to give me a positive number? And if the answer is yes, I'll put a 1 there. All right, so I take my number, subtract this 128 from that. If that gives me a positive result, I put a 1 here. And so then I actually do the subtraction, and I still have 114 left. So then I look and say, okay, well, I've already used the 128, so the next one we're going to look at 64. So we have 114 left. We're going to subtract 64. If that gives us a positive value, we're going to put a 1 there. Okay. And then we've got 46 left. We look at the next number, 32. So 46 minus 32, again, yes, that gives me a positive number, so I get a 1 here. And I have 14 left. Now, my next column is 16. Well, if I do 14 minus 16, that would go negative, right? That's going to give me minus 2. And so when you're doing this conversion, you just have to, if you go negative, then that means you're going to put a 0 in that spot. Okay, so I had 14 left. I tried to subtract 16, but that gives me negative. So I put a 0 in here and say we're not going to use that one. And then we look at the next one, which is 8. So now we still had the 14 left. So 14 minus 8, that does give me a positive result, right, with a remainder of 6. So that gives me a 1 here. And then so I have a remainder of 6. So then I subtract 4 from that. That gives me positive. So that's a 1. Gives me 2 left. I have 2 minus 2. So that gives me 2 minus 2. That'll give me 0, which is still considered positive. So that gets a 1. And then I've got nothing left over. Okay, so basically if 242 is an even number, then the ones column will always be a 0. If you're doing like, say, 243 or 241, your ones column would always be a 1 because that's going to give you the odd value. So when you're doing binary, this only really works for binary when you're talking even or odd. But if the rightmost bit in binary is a 0, then it's an even number. It's some multiple of 2. Some multiple of 2. Okay. So we can revert that and go the opposite way to go to decimal from binary. So here I just have like a different value of 1s and 0s, and then I just multiply it times their weighting. So we have 1 times 128, and then this was just 0. So 0 times 64, 0 times 32, those are just 0. And then you add all these values together, and that will give you the decimal equivalent. Okay, so it's very easy to convert using this kind of layout here to convert your numbers. All right, now there's also what they call an octal numbering system. And in the octal numbering system, you basically work on values of 3 digits.